Here's my version of a magnet to pick up pennies and dimes, and I don't have any gold. It would actually work on gold, given a similar size. Inside here is a core of ferrite material, a copper washer on top, and the hole is useful for assembling it, but not necessary functionally. And then I've added ferrite plates at the bottom, which help with the efficiency a little bit, but aren't critical. And then a coil of wire around it, with concentrated towards the top, and I'll turn this upside down to pick up coins. So that's the basic construction. And then this one is higher frequency than the 60 hertz ones, because that fits small objects better. And so this is a ZVS oscillator, like you see a lot of induction heater circuits. This happens to be a homemade one that I had laying around already, had modified a little bit. But that just drives it with about 9 kilohertz instead of the 60 hertz. I have a switch here, turn the magnet on and off. It's an electromagnet. And then the pennies are actually the hardest because this is sized a little better for dimes. But there we go. Got the penny picked up, and then I turn off the magnet. And the dime doesn't need to be aligned quite so well. And the aluminum is easy because the aluminum is light. Here's a bottom view looking through the plexiglass sheet that everything's set on. And I can just go ahead and pick up the dime. This is the edge view of picking up a dime. When picking up something much thinner than a dime or a penny, so therefore lighter, this is just a piece of thick aluminum foil cut to about the size of a dime. And that can be picked up from about 3 times as far. It's about 5.5 millimeter jump instead of the 1.5, 1.7. Squares and rectangles also work. These shots are looking at the bottom through a mirror. It's convenient. So now I have some aluminum foil discs, which are lightweight, so actually easy to pick up. I have one about then you're dime sized, and then down to 6 millimeters and up to quarter sized. And so, since this was designed for dimes, it's really trivial to pick up. And we can go a little bit larger, nickel sized. But you get bigger than that, and it barely works. And we can go somewhat smaller too. Down by 8 millimeters. No luck. It'll bend it up a little bit, pull up one edge, but it won't lift it up. And this size issue is common to all such magnets. People get excited when they hear of a gold magnet. This one would actually work on gold if it was the size of a dime. But here's a bunch of little bits of aluminum foil. This kind of simulates, suppose you were trying to pick up gold flakes out of some ore or something. You get none whatsoever. And that's because this works by setting up eddy current around the rim of whatever you're picking up. So you pick up an aluminum disc, it's the current that's induced around the rim of it that causes it to be lifted. Magnetic field is coming out from the edge of the ferrite that you can hardly see here, between there and the winding and the copper that blocks the center field. And so it's that field coming out there that expands, and including expanding inward to go around the object being picked up.
Here's a FEM simulation showing the magnetic field lines. So you can see the penny or dime at the bottom, and the magnetic field lines actually curve around underneath the dime or penny, and that's what gives it the lifting force. It's essentially being pushed from underneath, even though there's no structure underneath, because the field lines that are coming out just outside the diameter of the coin expand outward mostly, but some of it expands inward and lifts up the dime or penny. And because a lot more of it goes outward, that's why this is relatively inefficient, but it can actually pick up objects like dimes.